Section 8.6, we're going to be talking about compound inequalities. So a compound inequality is formed by joining two inequalities with an or an and. For example, I have two inequalities with an and linking them. I have two inequalities with an or linking them. There's also a more compact way to write sum and problems, and that is by having the two inequalities with my variable expression in the middle. To solve these inequalities, what we're going to do is we're going to solve each inequality separately. So if I have the word and or in the middle, I just solve each problem on its own. If it's a compact inequality, then we're going to isolate the variable in the middle. And so I would whatever you do on the middle, you do to both outsides. And then we're going to graph the solutions on a number line and then write our solution in interval notation. Just a couple of extra notes. When we have the or inequality graphs, they point away from each other and the solution sets will be joined with a union symbol. When we have the and, the graphs point toward each other, and the solution will be written as a single interval. So some problems to solve. Example, part A. Well, I'm going to solve each one of these inequalities. And add 5. And divide by 2. And then I'm going to jump over to the other one. I'm going to solve and here I have a fraction, and I'm going to leave it just in simplified form. 7 over 2, that's also, if we make it a mixed number, is 3.5. We need to graph. And so I have x is greater than 2. I also have x is less than or equal to 3.5. And when we go to graph these, we're not going to use maybe what you've used in the past, which is open and closed circles. We're going to use the interval notation symbols. So we're going to use parentheses for less than or greater than, and we're going to use brackets when we have the or equal to's under them. So x is greater than 2. On 2, I'm going to use a parenthesis opening to the right, since the direction right is greater than. And then x is less than or equal to 3.5. So at 3.5, I'm going to use a bracket pointing left, because that's the less than direction. And my solution is the area in between. So then to write in interval notation, all I do is just kind of drop the number line out of it. And I have parentheses on the 2 to 3.5 with a bracket. Now we're going to do a whole bunch more of these. So we're going to solve Don't forget the extra rule when solving inequalities. If you divide or multiply by a negative, you have to change the direction of your inequality sign. I draw on my number line. I have x is less than 3, so parenthesis on the 3, going left. X is less than or equal to -4. Bracket on the -4, also going to the left. So this one's kind of a strange answer because they're both pointing to the left. So to determine my answer, I need to think about my word. My word's and. So my answer is everything that's less than 3 and also less than or equal to -4. So all of these numbers in between the 3 and the -4 are not part of my solution because they don't fit into both of them. It has to be both of them. So my answer is only what's to the left of -4. So in interval notation, we go -infinity to -4. Remember, infinity always gets a parenthesis. The 4 has a bracket because it's got an or equal to on it. Part C. When I graph my answers, less than 4 is a parenthesis on the 4 going left. Greater than 7 is a parenthesis on the 7 going right. Since my initial problem is an OR problem, I'm going to have 2 separate pieces to my answer. So I have -infinity to 4, parenthesis. When I have that gap in the middle, I use the union symbol, and then 7 to infinity. Part D, switch my direction because I'm dividing by -3. Switch my direction because I'm multiplying by -2. When I graph this, x is greater than or equal to -1. 6. X is less than 6. I have an OR in the middle. So I need all my answers going to be all numbers greater than or equal to -1 or less than 6. So in this case, we're not just stuck in between. It's everything greater than or equal to -1 or less than or equal to 6. So it actually ends up shooting past my boundaries because it's an OR problem, and kind of shading in both directions, which is represented with -infinity to infinity. Part E is a compact inequality, so I'm going to solve this by getting my variable by itself in the middle. Dividing by -2, so I'm going to switch the direction of the signs. Oops, it's 3. And when I graph this, I look at one inequality at a time, so I'm going to cover up the 4 side of it, and I have 3 is greater than or equal to x, or if I read it backwards, x is less than or equal to 3. And this side says x is greater than -4. Compact inequalities are AND problems, so my answer is just going to be the region in between my 2 boundaries. There's another AND problem. Multiply by 2/3. Divide by -1. So I have x is greater than 2 and x is less than -4. If you think about the wording behind that, the word "and" in the middle. You cannot be both greater than 2 and less than -4. It's not possible. So my answer is that there is actually no solution. And that's the end of the section.